Welcome to T3 Day 24 of Calculus. Today we're going to continue our discussion of definite integrals with W substitution. Remember, good candidates are functions where you have a difference in power of 1. So there's a power of 2 there and a power of 1 on the front. So this is a good candidate. We're going to pick W equals x squared, do the derivative, get dw equals 2x dx, and isolate x. So we get dx is equal to dw over 2x. And now we do the substitution. So we do integral of x e to the x squared is w, because that's the substitution we're making right there. So we continue and get, instead of dx, dw over 2x. And that magical thing happens where these x's cancel, and we're left with just the integral from e to the w dw. Now what's nice here is that I've dropped the limits of integration, but they're still there. They're 0 and 2. These right here are x values. These are both x values. What's nice is that once we go into w land, meaning we go into using w instead of x, we can't keep using these x values. We have to turn them into w values. So you plug 2 into there. What's 2 squared? Well, that's 4. And what's 0 squared? So you plug 2 and 0 into there. 0 squared is 0. So our new limits of integration are 0 to 4. This is nice because it means we don't have to plug back in. We don't have to plug back in. So what are we going to do? We integrate. That's going to be the integral of e to the w is e to the w. So it's from 0 to 4. So that's going to be e to the 4th minus e to the 0. So that's e to the 4th. Oh, and there's a 2 there. That got factored out there. So there's a 1/2 out front of this. So it's a 1/2 and a 1/2 like this. So what do we end up with? 1/2 times e to the 4th minus e to the 0. E to the 0 is 1. So you could write this as 1/2 e to the 4th minus 1. So what's nice here is once we went into w, as long as we change the limits of integration to w values, as long as we change them to w values, we don't have to go back to x to finish the evaluation. We don't have to go back to x. But the key is, once we're using w's, we have to make sure these, the limits of integration, are in w. So let's do the same thing here. In this case, w is going to be 5 minus x, so dw is going to be negative dx, because the derivative of 5 is 0, and the derivative here is negative 1, but it's negative 1 dx. So what does that mean? It means that dx is equal to negative dw. Now we substitute integral of 3 over w, and then we write, instead of dx, we're at negative dw, like this. And what are our new limits of integration? Well, we take 3, and we plug it in there, and we end up with 2, because 5 minus 3 is 2. And we take 1, and we plug it in there, and we get 4. So it's 4 right here. So what does this equal? Well, we can factor out the 3 and the negative. This is equal to negative 3 times the integral from 4 to 2 of 1 over w dw. Can rewrite that a little bit. If it makes you feel better, we could flip the limits of integration. Let's flip these. If you switch them, it makes the outside negative, so it turns the whole thing positive. So it turns into 3 integral from 2 to 4 of w to the negative 1 dw. It's not necessary, but I like getting rid of negatives. The integral of w to the negative 1 is ln of the absolute value of w, so you have 3 times ln, the absolute value of w, evaluated from 2 to 4. So what's that going to be? 3 times ln of 4 minus ln of 2, like that. And if you remember your log rules, subtraction means division, so it's 3 times ln of 4 over 2, so that's 3 ln 2, like that. So cool. As long as we change the limits of integration, once we are in w, we have to make sure our limits of integration are w. So don't forget to convert them. So now we're in trig land, and one thing to remember is that we should, if we can, simplify. So what does this equal? This is, I'm going to keep it as the same thing. I'm not going to change the limits of integration by doing any substitution yet. Tangent is sine over cosine. So this is sine of x, not theta. Sine of x over cosine of x, and both of those are cubed. And it's all over cosine squared of x dx. So if we keep on simplifying, I haven't done any calculus yet. This is going to be sine cubed x over cosine to the 5th x dx. Now let's do substitution. We got the tangent out of there. Let's let w equal cosine x. So dw is going to be negative sine of x dx. So dx is dw over negative sine of x. We're doing the same thing we did before. We pick a w, we do the derivative, and now we substitute. Now when we substitute in, it's going to be the integral of sine cubed x over w to the fifth, because w in this case was sine. And instead of dx, we write dw over negative sine of x. Now, some of this is going to cancel. We get a negative outside, and then one of these signs cancel. So you get negative sine squared x over w to the fifth dx. And you'll notice I did not put the limits of integration in. Let's do that now. So if we were to put limits of integration, is pi over 4 has to go in here to cosine, and so does 0 has to go into cosine. Cosine of pi over 4 is root 2 over 2, and cosine of 0 is 1. So now we're fully in W land. We're fully in W land. So we're there, but there's something that's, you notice, is a little off here. We're now at this thing right here, but you'll notice that this thing has an x in it and a w. You can't have two variables. We need to go down to one variable. The one substitution we have is we know that w, this is what we did at the beginning, is equal to cosine of x. Is there anything we can do here? Is there any relation between sine and cosine? Well, let's square both sides. We can do that. It's still true. Well, that has to be true. We're almost there. It's not quite there yet, though. But we also know, just as a trig identity, sine squared x plus cosine squared x is equal to 1. Okay, so sine squared x plus cosine squared x is equal to 1. Okay, so what can we do next? I mean, this looked like it could help, but not really. So what about this? Well, it tells us that sine squared x is equal to 1 minus cosine squared x. Do we have a sine squared in there? Oh, we do. Oh, and we know, oh, what do we know here? We know that this was going to be, oh, look at that. Don't throw it away that easily. We know that cosine squared is equal to w. So what does sine squared x equal? 1 minus w squared. Oh, that's super cool. 1 minus w squared. So we take this and we plug it in there, and what do we now have? Negative integral 1 root 2 over 2, 1 minus w squared over w to the fifth dx. Sorry, dw. Did we do the substitute? We did, and I didn't place it. It should be dw right there. Notice when I plugged it in here, this should have been a dw, and this is now a dw. Sorry. Okay, so we have this. It's still a little ugly, but how many variables do we have? We just have one variable, w. What can we do here? Well, we can always simplify it. So what do we have here? Negative root 2 over 2 on top and 1. And this is just going to be 1 over w to the fifth plus, we're going to break this apart into 2, well, minus w squared over w to the fifth. All I'm doing is breaking it apart into two fractions. This became those two fractions right there, right? So let's simplify. What does that become? 1 root 2 over 2. This is w to the negative 5. And what does this become? Well, that's 1 over w to the third minus w to the negative 3 dw. And now those are two things you can just integrate. What are they going to integrate to? Well, I want to get rid of this negative first. I'm going to multiply it in. So if I multiply this in, what does it become? The integral from 1 root 2 over 2 w to the negative 3 minus w to the negative 5. You just reverse the subtraction. I just want to get rid of that negative. So now we're at this thing, which we absolutely can integrate. What's that going to be? Well, you go up 1 power to negative 2, and you go 1 over negative 2, and then it's going to be minus 1 over negative 6, not negative 6, negative 4, w to the negative 4. Remember, you got to go up a power. What's 1 up from negative 3? Well, that's negative 2. And what's 1 up from negative 5? Well, that's negative 4. Remember, whatever's up here has to go down there. Whatever's up here has to go down there. So this is going from 1 to root 2 over 2. So when we simplify that a little bit, I'm going to simplify that there's two negatives there. See the negative there and there? This becomes negative 1/2 w to the negative 2 plus 1/4 w to the negative 4 from 1 to root 2 over 2. And if you do this all out, it's a lot of fractions, but when you square this, you get rid of the radical. When you do this all out, it becomes 1/4. I'll let you do that out on your own. So let's do a couple more practice problems. On this one, let's keep it the way it is, but let's multiply it out first. X plus 1 times x plus 1 is x squared plus 2x plus 1, and that's all over x. So I'm just doing this out. I haven't done any calculus yet. So what does this simplify to? It's 3 to 5 of x squared over x plus 2x over x plus 1 over x dx. So what's that going to simplify? 3 to 5 of x plus 2 plus x to the negative 1. Now we can just do the integral of that without using substitution. That's going to be 1/2 x squared plus 2x plus ln of x from 3 to 5. So you plug in 5 and you get 1/2 times 5 squared plus 2 times 5 plus ln of 5. And then what do you subtract? Well, 1/2 of 3 squared plus 2 times 3 plus ln of 3. And you can simplify that a little bit, but that would be the final answer right there. So in this one, it looks like you might not be able to do something, but if you take the denominator and make that w, you then take the derivative of both sides and isolate for dx, plugging it in right there. Now you need to change the limits of integration. Instead of 2 and negative 2, you take both of those numbers and plug them in there. So it's 4 plus 2e to the negative 2 and 4 plus 2e to the 2. That should be a 2 right there. So now what cancels? Well, the e to the x cancels, and this 2 goes to the outside right there. So you end up with 1 over 2, the integral from 4 plus 2e, 4 plus 2e to the negative 2 and 4 plus 2e to the 2, w, 1 over w dw. Well, this is kind of nice because we know the integral of that, that's w to the negative 1. The integral of that is just ln of the absolute value of w. So from 4 plus 2e to the negative 2, 4 plus 2e to the 2. So what do you end up with? 1/2 ln of 4 plus 2e squared minus 1/2 of ln of 4 plus 2e to the negative 2. So on this one, you let w equal the square root of x. So then you take the derivative, and then when you isolate dx, you get this wonderful thing that'll help you cancel everything. So that's what you do to substitute there. I'll let you finish this one on your own. And then here you have two choices. Should you let w equal cosine of 6 theta, or should you let w equal sine of 6 theta? Which one? Try both, see which one works well.